Welcome back. I'm excited to introduce you to Fernando de Sales, an associate professor of geography at San Diego State University. Dr. de Sales will talk with us about how his research can help us to better understand the impact of deforestation on the hydrological or water cycle. From the perspective of a climate scientist, why is tropical deforestation a problem?
Well, photosynthesis in forests removes CO2 from the atmosphere, which helps regulate the global temperatures. So from a global perspective, deforestation results in more atmospheric CO2 and global warming. Deforestation also reduces evapotranspiration. So from a regional perspective, it leads to drier and warmer near surface conditions, which may even reduce precipitation.
So do you think you could define a couple of those things for me, for people that might not know these terms? Do you think you could tell us what photosynthesis is first?
Yeah, photosynthesis is the process used by some plants to generate energy by converting sunlight and carbon dioxide from the atmosphere in glucose.
Okay, and then evapotranspiration.
So evapotranspiration is actually a combination of two words, evaporation and transpiration. So it's both of those are loss of water from the surface. So there are processes that move water through vapor to the atmosphere, either surface water or through photosynthesis.
Okay, so when you cut down the trees for deforestation, it means that you're reducing the evapotranspiration rate. Is that right?
Yes, you remove the amount of trees, so therefore there's less evapotranspiration.
So that means there's less water that ends up in the atmosphere, and there's less water that can rain down.
That is true.
Come down as rain. Yeah,
yes.
Probably would. Climate scientists might not explain it that way, but my simple version. Okay, so how then is tropical deforestation related to climate change?
Yeah, that's a good question. So deforestation weakens the biosphere's ability to fix CO2 in biomass, right? So on top of that, decomposition of dead trees and fires that usually follow deforestation can further worsen the problem, as both of those processes, decomposition and fires, emit CO2 to the atmosphere. Long-term climate projections seem to indicate that conditions in the Amazon will get drier in the future, which could be, of course, exacerbated by large-scale deforestation.
Okay, so tell me more about these links between deforestation and the hydrological cycle. My understanding is that they're different at the regional scale and the larger global scale.
Yeah, you're right. So studies suggest that large-scale deforestation can increase local rainfall by enhancing convection. On the other hand, large-scale deforestation will reduce rainfall and weaken the hydrological cycle. For example, in a 2020 study that I was part of, we showed that large-scale deforestation can shift rainfall patterns in the Amazon. Our climate model simulations indicated that further large-scale deforestation in the southwest part of the Amazon specifically will decrease rainfall in local urban centers and settlements. And that is because of a decrease in evaporation and an increase in wind speed in the forested areas.
Okay, so is it that small-scale deforestation might not have impacts on the hydrological cycle? It's only large-scale deforestation where you see these effects?
Yeah, we see that small-scale deforestation, it may cause more rainfall because you expose the ground, so the ground gets slightly warmer, which may lead to a cloud formation over that area, which they may or not result in more rainfall there. But when we talk about large-scale deforestation, then the effect is the opposite. We always see less rainfall over those areas, over the deforested areas at least.
Okay, yeah. Yeah, so this effect is pretty complicated. So it's different according to the amount of deforestation and the area that you're talking about, right?
Right.
Okay, so can you tell me if this leads to any feedback effects that we should be concerned about?
Sure. I think it could. The Amazon rainforest climate is a wet climate, which is not favorable for large, extensive fires, right? So, however, if future climate projections come true and the Amazon becomes drier in the future, we would see more and larger fires there, which could further reduce precipitation and even transform parts of the Amazon rainforest into a savanna-like environment.
Yeah, and just to make sure that everybody's on the same page here, what is a feedback effect? Can you explain what's meant by that in this context?
Of course. So feedback processes are processes that either enhance or weaken the initial process that caused it to happen. A very good example of a positive feedback is a snowball, right? As the snowball goes down a hill, it collects more snow. The ball itself becomes larger, which then collects even more snow as it continues to go down the hill. So that's a typical example that we use. We also have negative feedbacks in climate, and those are processes that weaken the initial forcing.
Oh, that's really great. I like the snowball analogy. That makes it really easy to understand. So I think Brazilian deforestation is a really good topic for this course because there's a lot of positive change that happened during the time period after 2004 that we can draw from, right? We're focusing on climate solutions in this class, so what can we learn from that period of deforestation that was in decline that can help us figure out how to solve deforestation into the future. But right now, I know that most of those policies are not being followed, that deforestation is on the uptick, and right now, actually, deforestation in 2021, I think, is the highest it's been in the last 10 years, maybe 2 decades. So what do you think that climate projections, how do you think that climate projections might change if current deforestation policies are enforced?
Yeah, well, I think it's difficult to say. Greenhouse gas emissions will probably increase as developing and developed countries' energy demands continue to grow over the next decades, even if deforestation policies were enforced, right? That would continue to enhance global warming. So I think that more studies on the individual contribution of global warming and deforestation are needed to answer that question.
So what I think you're saying you would conclude too is if we're going to address climate change in the future, that we need to focus on deforestation, but not only deforestation. Energy is an important sector to address reducing carbon emissions in as well.
You're right. Yes, if emissions continue to grow, we would still see drying conditions in the Amazon, probably regardless of how much more deforestation would happen there.
Yeah, so you're bringing up something that I wasn't even linking, but that's really important. So I think I want to ask you about that again. So what you're saying is that, of course, if emissions from energy continue to increase, even if we slow deforestation, climate change is likely to continue to happen. But what you're pointing out is that even if we stop deforestation, if we continue to emit CO2, the Amazon may still dry up. Is that right?
Yeah, some model simulations indicate a drying of the Amazon in the future because of global warming, right? So because of greenhouse gas emissions in the atmosphere. So we do need more studies that can separate those two forces, right? One is global warming, the other one is deforestation. Of course, they're happening together right now, but we need to understand, the individual contribution of those two to better assess the future.
And if that happens, do you think there'd be positive feedback effects then too, that could lead to a desertification of the Amazon? I guess that's the extreme, and you probably, as a climate scientist, would never go to the predicting extremes. But is that something we should be concerned about?
Yeah, because both of those, as of now, at least as far as we understand, both of those processes, global warming and deforestation, they have a drying component to the Amazon. So what we don't know is if combined, if the effect would be just twice as worse, or there's some feedbacks happening there that we're not very clear about. We have some idea about fires. So if the Amazon continues to dry because of global warming and because of deforestation, and then on top of that, we do have more fires in the region, that would certainly lead to, this more savanna-like environment in the Amazon, meaning less, drier and less vegetated surfaces than we have now.
Thank you, Dr. DeSales. It was interesting to learn more about how deforestation and climate change feedback effects may result in significant impacts on regional and global water cycles. Thank you for watching.